All right, so today we're going to talk about deductive reasoning, and it can be defined as a type of reasoning that uses facts, definitions, it uses accepted properties and the laws of logic, and it's to form a logical argument. So basically, deductive reasoning is more fact-driven, whereas inductive reasoning is you're making a conjecture based off of a pattern. So it's kind of like inductive reasoning, you're basically making it like a really good guess, and deductive reasoning is you're using the facts to make a conclusion. So again, that's what I just said. This is different from inductive reasoning. Because it uses specific examples and patterns to form a conjecture. And remember, again, the conjecture is just kind of like an educated guess. A really good guess, a good guess, or it's basically a conclusion from the pattern. There are some types of deductive reasoning. The first one is the law of detachment. So basically what that is if the hypothesis of a true conditional statement is true, then the conclusion is also true. So the law of detachment is also called a direct argument. And we'll talk about what the law of syllogism is, and then you'll see the difference between the two once we see the examples. So law of syllogism is also called the chain rule. So basically, it's a sequence of events. It's like one thing leads to the other. And law of syllogism, a perfect example of the law of syllogism, are the direct TV commercials. This is where, remember, if you have cable, then you end up in a roadside ditch. It's where one thing leads to another. And it's kind of not necessarily a sequence of true events. It's just one thing is always affecting the next. All right, so we're going to use the law of detachment to make a valid conclusion in the true situation. So this is the example so you can see the difference. If two segments have the same length, then they are congruent. You know that BC is equal to XY. So again, in the law of detachment, it says that if the hypothesis is true, then the conclusion is also true. So basically here in the hypothesis, they're telling you that, okay, if the segments have the same length, then you can go ahead and say they're congruent. So we know that they have the same length because BC is equal to XY. Therefore, we know that BC is congruent to XY. So that's our conclusion. If the hypothesis is true, then you can conclude that the conclusion is also true. Next, in B, it says Mary goes to the movies every Friday and Saturday night. Well, first, you have to identify the hypothesis and the conclusion if it's not given to you in an if-then statement. Because the first one was given to us in an if and a then. So remember, anything after the if is the hypothesis. And when you come after the word then, that's the conclusion. So we need to state this sentence in an if-then form. So if... And I'm going to abbreviate. So if it's Friday or Saturday night, all right, then Mary goes to the movies. So Mary goes to the movies. So that's your hypothesis here. If it's Friday or Saturday night, then your conclusion is then Mary will go to the movies. So they have basically told you, okay, well, today is Friday. So if I were just to come up to you and say, hey, today is Friday, and you already knew that if it was Friday, then Mary goes to the movies, then what you can go ahead and conclude based off of facts, because today is Friday is a fact, then you can go ahead and say, all right, well then Mary went to the movies. So you're using a fact that today is Friday to make a valid conclusion. So that's the law of detachment, when you must say that the conclusion must come first. You must know the hypothesis is true. If you know the conclusion is true, you cannot make a valid conclusion. You have to know the hypothesis is true. All right, so if possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So I always think of law of syllogism also as a silly story. So, because one thing leads to the next, and they're not necessarily all like related. All right, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So what you can see here is this conclusion is restated. So here it is the conclusion, and then in the next conditional, it's the same, but this is now the hypothesis. So basically, if the conclusion leads you into the hypothesis, then you can go ahead and conclude based off of facts that if Rick takes chemistry, then he will get an A. So if Rick takes chemistry, then he gets an A. And I'm just going to abbreviate again. So basically, the part that is repeated, do you see how here, like the conclusion, again, is repeated as the hypothesis. Basically, those kind of go away, and you can almost like cross them out, and then you just make a new conditional, a new if-then with what is left. So here, you just have to make sure that the same parts repeat. If x squared is greater than 25, then x squared is greater than 20. The next statement is, if as x is greater than 5, then x squared is greater than 25. Now this one at first, it looks a little tricky because you're looking at this conclusion and you're wanting it to repeat here for this hypothesis. However, you can switch the order of the sentences. So if I switch the order of these two statements, and let's say this one came first, and I said if x is greater than 5, then x squared is greater than 25. Then I wrote if x squared is greater than 25, then x squared is greater than 20. So here then, this becomes the conclusion, and it is repeated here as the hypothesis. So now you can make a valid conclusion and say if x is greater than 5, then x squared is greater than 20. So again, be careful. What this is showing you is that you can switch the order of the sentences around if it helps you make a valid conclusion. Let's look at the last one. If a polygon is regular, there's your hypothesis, then all angles of the interior of a polygon are congruent. So here's your conclusion. Is the conclusion repeated? It says if a polygon is regular. You can see that neither of these conclusions here are the same. So basically this one is not possible. And that be all.